Alright, so far we have learned the different characteristics of quadratic functions. We've learned how to solve quadratic equations. And now we're going to learn how to describe transformations using function notation. First of all, what is function notation? Function notation is just f of x, okay? F of x is just a name. They can also call g of x, h of x, and any other combination. It could be k of x, q of x. Anything like that is just function notation, and that's the name of the function. F of x is also the same as y. It's your output. It's the function value. Okay, and in terms of transformations, f of x is also known as the pre-image, which is the original graph or the original function. All right, let's get into the transformations. So transformations, we know a flip. A flip occurs when a is negative. The way you would write that in function notation is you put the negative in front of f of x. All right, next we have a stretch. A stretch is when a is between 0 and 1, meaning a fraction. And you guys saw that on your worksheet from yesterday on the characteristics of different quadratic functions. A fraction will cause your graph to stretch. So an example of that is 1/2, 3/4, 5/8. Those are all fractions that are less than 1. A non-example would be a fraction like 11/3 because the numerator is bigger than the denominator, so that fraction is greater than 1. Or 8/5, same thing. 8 is greater than 5, so that fraction is greater than 1. So that would not make your graph stretch. Okay, the way you would write that in function notation is you would put a number. I'm using q to show to represent any real number. You would put that number in front of f of x, and then you would make a restriction where that number is between 0 and 1, letting the reader know or the student know that it's a fraction less than 1. Next, we have a compression. A compression is when your a value is greater than 1. So an example of an a value that would make your graph compress would be 2, 5.5, 7/4. All of those numbers are greater than 1. And the function notation for that is the same. You would write any number. I'm representing that by q. So I have q, f of x, and then I make a restriction that q has to be greater than 1. Next, let's talk about horizontal movements. All right, sorry, my phone rang, but let's talk about horizontal movements, left and right. So for your graph to move left, you have to have a plus h in your equation next to the x. And the way you show that in function notation is you take f of x and then you add a number inside the parentheses with x, just like you would do in the equation. If you want to move your graph to the right, you have to have a minus h. And so to notate that, you would put a minus q or minus any number to show that you're inside parentheses to show that your graph is moving to the right. All right, next let's talk about up and down. So when your graph moves up or when your graph is moving up, you need to have a plus k on the outside of parentheses. And the way you would show that is adding a number on the outside of parentheses to your function f of x. So here I have f of x, close parentheses, plus q. All right, and down is very similar. You just need a minus k instead of a plus k. And then to notate that, you will put the minus q or minus any number outside of your f of x. So the function notation for moving the graph down is f of x minus q. All right, so now we're going to do a couple examples. Describe transformations using function notation. Here are the transformations. I chose up 2 and left 4. And this is how you would write it using function notation. You see I had the plus 4 inside the parentheses with the x to show that my graph is moving to the left. And then I have plus 2 on the outside to show that my graph is moving up. Next example, stretched by 2 and right 1. So remember, whenever your graph is stretched or compressed, you have to take the reciprocal of the number that it was stretched or compressed by. So I have to take the reciprocal of 2, which is 1/2. So I put that number on the outside in front of f of x. So I have 1/2 f of x minus 1. and the -1 is to show that my graph has moved to the right. All right, next there is a U-try. Compressed by 1/3 and down 6. So pause the video so you can try yourself. To compress a graph by 1/3, I first have to take the reciprocal of 1/3, which is 3. Okay, I put that in the front because that's going to be my A value. Remember, A tells you whether your graph stretches or compresses. Then I write F of X, and I'm going to close my parentheses because I don't have any horizontal translations like left to right. I only have a translation that moves it down. So I close my parentheses, and -6 will move my graph down 6 units. All right, if you have any questions on this video, you can ask me or you can post them on Google Classroom, and I'll see you guys next week.